Okay, so now we've got our third method. So our third method is going to be using square roots, okay? So we only want to use square roots if we notice that the equation has a bunch of perfect squares in it, okay? So use this method. Use if you notice perfect squares. Okay, so I think the best thing to do is to just show you an example, right? So example C, let's say we've got something that looks like this. Let's do 9x squared minus 36 equals 0. Okay, so if I'm looking at this one right here, I'm going to notice that I have two perfect squares. 9 is a perfect square, and 36 is a perfect square, and x squared is obviously a perfect square as well. So I've got a bunch of perfect squares and nothing else, just perfect squares going on. If that's the case, then I know that this is actually going to be pretty easy to solve. So first we're going to notice the only values I have are all perfect squares, which means this is the one method that you can just solve straightforward. There's no trickiness that you have to use. There's no methods. There's no formulas. You literally can just solve for 0, or you can just solve for x by moving all the numbers away from it. So let's go ahead and do that. 9x squared minus 36. And we're just going to use backwards order of operations. So at the back end of order of operations is addition and subtraction. So we're going to add 36 to both sides, giving us 9x squared equals 36. And then the next step up from order of operations is multiplication division. So we're going to divide by 9, which gives me x squared is equal to 4. And then the last step is exponents here. We don't have any parentheses, so exponents, we take the square root of both sides. And then we notice that we get two different answers here, right? So every time you take the square root, that's always going to split your answers into two. You're going to have a negative answer and a positive answer. So I get x equals -2 or x equals +2. And that's my answer. So this is pretty straightforward. You should be able to identify if using a square root is actually the easiest method. And this is probably the easiest one to see, in my opinion. Now let's move on to one that's not so easy to see, but is my personal favorite method out of all these. It's my favorite way to solve these. It's the one that makes the most sense to my brain. And that is completing the square. Which is very, very similar to using square roots to solve. Okay, so we only want to use the completing the square if, so use if either a is equal to 1, or if you can divide away the a easily, or if you can divide by a easily. Okay, so if you can get rid of the a value, or if you don't have an a value, you just have x squared in front. This is the first thing to look out for, which is very similar to factoring. But the main difference here is to notice that if you have a equal to 1, and the b value remains even. Okay, so we're going to use this method if either a equals 1, or if you can divide by a easily. We'll put quotation marks around a, so that way we know that we're not talking about the word a, but the value a. easily, and the b value remains even. Okay, so let's do an example so you can see what I mean. Example D. So example D, let's say we have, let's do x squared plus 8x minus 2 equals, what's a good one to do? Sorry, this is going to take me a second. Let's do 18, okay? So for this one, I'm going to notice two things. First off, I notice the a value equals 1, so there's nothing written here. The a value is gone. And notice that this is an even number, okay? The reason why this is important and why we want an even number is because when we go to complete the square, we don't want to have to deal with cutting this in half and getting a crazy decimal, right? We don't like decimals. We don't like fractions. We're going to just stick with whole numbers or integers. We don't want any of that stuff, okay? So that's why it's important to make sure that this is even first, okay? So first step to this, let's go ahead and solve this by completing the square. X squared plus 8x minus 2 equals 18. Okay, so we're going to add 2 to both sides if you can remember how to complete the square, giving us x squared plus 8x equals 20. And then now I need to add the new add the new c value. So the new c value we get by b over 2 squared. Okay, so let's do that here. So b over 2 squared. I'm going to draw an arrow so we can do the math over here and save some room. So my b value is 8 over 2 squared. 8 over 2 is 4 squared equals 16. So that's my new c value. So I'm going to add 16 to both sides, and that gives me x squared plus 8x plus 16 equals 36, okay? Okay, then my next step is to change this to factored form. So I'm going to change this to factored form. I know that my factored form needs to be a factor squared, right? So it's going to be identical factors. That's the whole reason why we did this piece, because we know doing this piece will give us an identical factor, right? So we get x plus, and then we usually always get this number right here, right? That's the number that goes right here, because 4 plus 4 equals 8. 4 times 4 equals 16, okay? So I want 2 of those. So instead of writing it out twice, I'm just going to write a squared to make it easy. Equals 36, okay? Take the square root of both sides, and this is where the split happens, right? Okay, so I'm going to get 2 different answers here. Here's where I get, let's see if we can finish this on this page. I'm going to start it right here, okay? So here I get x plus 4 is equal to plus or minus 6. So I'm just kind of writing this just to make it easy. So when I go to subtract 4 from both sides, I'm now subtracting 4 from 2 different numbers. I'm subtracting 4 from positive 6 and from negative 6. So let's see what 2 answers I get. So when I subtract it from positive 6, 6 minus 4 equals 2, or x equals negative 6 minus 4 equals negative 10. And that's my answer there. Okay, so that's how we do those 2 methods. Now I got one more method for you before I give you some practice problems. So this next one, and this is the last one, is if all else fails, if you don't like any of these methods, or all these methods are way too complicated, and you're not finding that it's actually that easy to solve this, what you're going to have to do is you're going to have to use the quadratic formula. Okay, so this is method number 5. So method number 5 is the quadratic formula. And what we just got done proving is we just proved that if you have something set up, if ax squared plus bx plus c is equal to 0, then we know that we can just plug in all these values into this formula right here, negative b plus or minus the square root of b squared minus 4ac all over 2a. Okay? So this is the quadratic formula. We're just going to use this if all else fails, right? So use if other methods are too difficult. Okay? The reason why I try and stray away from this method as much as possible is because this is, in my opinion, this is the longest method. This one takes the longest. You have a chance to make a lot of mistakes during this method. So I try and stay away from this one as much as possible. I also just, I think these other methods are faster. Like, look how fast factored form is if you have something that's set up in factored form. Look how fast, well, graphing was kind of a bad example. Look how fast solving by square roots was if it's set up for it. And then for me, it's actually makes sense for my brain, and I think it's still faster, even though there's a lot of work to be done to complete the square, okay? If it's set up that way, if you have an even number, then you don't have to pull out your calculator. You can do it all in your head. It works out a lot better. However, there's some that don't look really nice. So let me give you an example of example E of something that doesn't look really nice. So first off, let's create one that has like a really weird a value. So let's do like negative 3x plus, let's say, 2x minus, and then let's have like a really weird like 11 at the back here. So if I'm looking at this, I'm going to look at all my methods. I'm going to say the a value is not equal to 1. Ooh, yeah, and this, yeah, this just doesn't look nice. There's no perfect squares. None of the other methods are lining up nicely. These numbers are kind of weird. They don't really relate to each other. So I'm just going to use the quadratic formula to solve it. So what I want you to do is go ahead and try this one on your own. Plug this into the quadratic formula and see if you can figure out what x is, okay? And then we'll come back.